Okay, so one of the things I wanted to explain about the item analysis with Mastery Learning, Blackboard, by the way, it's Wednesday, 9 September. This is CSC 241 Computer Architecture, and we're reviewing some of the assessment items for our module on assessment. I'm explaining how the item assessment looks and works and feels. Blackboard is designed for traditional classes to assess, to provide statistical analysis of student responses to assessment items. We have true, false, multiple choice, and multi-answer questions. One of the things you're going to notice is that as students begin to master a concept, the discrimination, meaning the statistical differentiation or ability to analyze that item, starts to drop. So when everybody gets an item right, one of the things that happens with Blackboard is it says, hey, I can't calculate. I can't determine whether this is a good question, a fair question, a poor question, or it says I can't calculate this. So in a sense, mastery learning is something that they did not consider as they were working out the algorithms for the statistical analysis. The other thing I want you to see here is that if students get a lot of stuff correct, it tends to view those questions as an easy question. If fewer students get it correct, they tend to think of it as a medium or a hard question. And hard questions can also be determined based on the complexity of the answer choices and so on. We'll also have ordering questions and matching items where you match terms with definitions or objects with their descriptions. And those kinds of complex assessment items can bump up the hardness level. One of the things I'm looking for is to max out your understanding of the concepts. So a higher number for cannot calculate is actually good because it means that the material and concepts is understandable. The questions, the items on the assessment are easy to understand. And if everybody's getting it correct, it can't discriminate whether it's a good question, a bad question. So the higher the number of cannot calculate, I'm actually feeling pretty good about that. But I wanted you to understand the context. We normally try to have one or two hard questions, and we try to have a balance between medium difficulty and easy questions. Because easy questions are really more about content. You know, what color is the sky? It's blue. Medium questions are about application, taking an idea and applying it in a scenario or using it to determine an answer. Medium questions are actually, so this is a good mix in terms of difficulty. I'm going to go down to the bottom of the list. I'm going to go down to the bottom of the list and I'm going to pick some of the items that have a lower average score. Since the average score for each item was a 0.5, if I go ahead and sort by average score, I can put the difficult ones up to the top. So you'll see here there was a discrimination. This was probably one of the more difficult, you know, this is considered medium difficulty, right? If I click on this, it'll tell me some things about student answer choices. So here it's telling me how many students chose these three and how many students chose the fourth and fifth option. And you'll see that this answer was the most common answer most everybody got right. 7, 3, 2, and 2. So there were a couple of students that chose 4 binary ones must be present at the rightmost boundary. Probably because they saw this and they realized that F is all ones. So that was a question answer that was designed to be a suitable alternative, but it wasn't a correct alternative. So When you're shifting to the left, the ones in that F slide over and they're replaced with zeros. And you see nobody chose the last answer choice. So nobody was tricked by this last answer choice. We saw a lot of people that did not select this one. 4 binary zeros must be present at the rightmost boundaries. So most of you are going to, if you missed this, if you omitted this item and you were supposed to check it, you would say, I should have selected 4 binary zeros must be present at the rightmost boundary. We covered this yesterday. It is in the recording. So that portion of the recording from yesterday is still there. If you'd like to see the explanation for this particular assessment item, please reference the earlier part of yesterday's video, which is at the top of the resources folder. Any questions about this item before we continue? Okay, I'm gonna go back. I'll pick the next one. So the Boolean result of an open circuit, when I'm looking at a 0.5 complete score, if everyone got it correct, the fact that 0.33, that's like 2 out of 3 students got it correct is basically what we know. The true false item. So there were 5 students that said, oh, this is true. What I want you to remember or associate is that when a circuit is open, that means the loop of wire is broken open. So that's a kind of an audible thing. That involves some deep processing. Think of broken open, broken open, broken open, broken open. Is a light bulb on if it's broken? I want you all to repeat broken open, broken open, broken open real fast. If you're one of those students among the 5, that's what you want to do in your mind's ear. You want to say those terms real fast. Broken open, broken open, broken. If a circuit is broken, is the light bulb going to work when you flip on the switch? The answer would be no. If the switch is broken, if the circuit is broken, it's open, it's broken, it would be off. The light would be off and we'd have a 0 there. Any questions about this item? Okay, moving right along. So this one was flagged as a potentially poor question, perhaps. We have fair questions and poor questions with the statistical responses that students provided. It's probably because of some distinction, but it's always good to look at this. So the question reads, select all that apply regarding the bits used to represent a hexadecimal value. I did tell you that when there were multiple answer questions, you shouldn't just check all of the answer options, just as a default. However, in this case, all of them were correct or accurate, right? So select all that apply. All of them do apply. Regarding the bits used to represent a hexadecimal value, well, there are 4 of them. They are called a nibble. Binary digits are called bits. If you contract the word binary and digits together, you get the word bits, right? The B in binary and the ITS from digits, that's bits, right? And you preserve leading zeros, right? So if you have a hexadecimal value of 110, it's considered good practice to represent that nibble or hexadecimal value as 0110. That's what we mean by that. If you had a hexadecimal value of 3, that's the binary value of 11. The 1's place and the 2's place are turned on, and that's equivalent to the decimal value of 3. If you're going to represent the hexadecimal value of the bits, you'd put 0011. And here you see that fewer students chose this one, I think, compared to others. So anyway, that's the breakout for answer choices. What we should see is that everybody chose each of the answers, right? What does this mean? Top 25, second, 25, third, 25. bottom 25. If a student did the best in the class, they're in the top 25% of students. That's the top quartile of the class. So if you had like an A or a B, you had a 90% or higher, you'd be in the top 25%. The second quartile, if you did okay and you got a B or a C, you'd be in that second column. If you're a student who did all right, but not as good as you could have, and if you did poorly, you'd be in the last quartile, right? Any questions?
Question.
Yes. Was that a question? Yes, no?
No questions.
Okay. So here it said discrimination poor because of the way that the students answered. Everybody was, we had some scattered answers in each of the categories, but we didn't have strong answers from everyone. So it said it was a poor question. I don't rate whether or not my question is good or bad, but it's good to, if it's poor or right. All right, so let's keep going. We'll do this one yet. And then when we get to 40 or higher, that means 90% of the students got it correct. We can still review some of the other ones yet if someone requests. So the last one we'll review here, the Boolean hexadecimal value bad is doubled. I originally had an answer choice too bad, and thought somebody might go for that. But anyway, said the binary value is shifted one place. It's doubled, so that's an increase. That means we're shifting to the left. What's the binary value of BAD? Well, the original value of B is one more than A. What's the binary value of A? Anyone?
1010.
1010.
1010.
This is it right here. That's the value of A. That's A. And if you add one, you're just putting a one right here. You're actually putting a one right here. So it's 1011 is what you start with. So I'm gonna, just so I do this, I'm gonna say B is, right, make this big so everybody can see it. 1011, and then A is 1010, and then what is D? It's one more than C, and C is 1100, so D is 1101. I hope that's correct. Can we get a amen from everybody if that's correct?
Wait, for 14? No, it's 110. Wait, 1110.
It's 1110, it's not 1101?
Wait, no.
No, it's 1110. He's right.
Yes.
The first one was right.
Yes.
1110?
Yeah.
Yes.
Okay. So this is the 1100 is the value for 12, yes?
Yeah.
And 12 is, let's see, A, B, C. Hold up. So I'm going to cheat, right? So I'm going to use D.
No, D's 13, isn't it?
Yeah?
Yeah, DS 13.
Yeah, so then that's correct.
110.
1101,
Yeah.
not 1110. 1110 would be E.
14.
Oh, yeah. I forgot.
Okay. So we want to be sure about that. But I'm glad you spoke up because, we want to make sure we're on the right page. We're all on the same page. So this is B, that's A, that's D. Yes? We're going to take all this and we're going to shift it one to the left, which means we're going to add a 0 here on the end. And that's going to bump everything this way. So I'm going to add a 0 to the end of this. Well, let's just do it this way. Gonna add a 0. And now I'm gonna make these spaces more consistent. I have 4 on the end here. I have 4 here. I have 4 here. Whoop. And I need, if I'm going to do this right, I'm going to put leading zeros here. So that would mean, in terms of hexadecimal values, let's all do this together. I have new hexadecimal values. If I'm doubling bad, this becomes what? What is this?
1.
In hex, it's 1. It's also 1 otherwise, right? And what is this one right here?
7.
That's 7, that's right. 1, 7 in hex, right? What is this one?
5.
5, yeah. Because we have the 1s turned on, the 2s are off, the 4 is on, so that's a 1 and a 4, that's a 5, right? 1, 7, 5, and what's the last one? We know what the last one is.
A.
A. 175A. But that's the value we're looking for. So if we look at our answers, that's the only answer that works if you shift left. So this would have been a clue. If you shift to the left and you had this original value, you'd have to bump it into, you'd have a 4th nibble. There's only one answer choice with a 4th nibble. All the rest don't have enough nibbles, right? Any questions? Okay, does anyone want to see the other items yet? Would anyone care to see shift binary left or shift right? Anyone? That's okay.
Sure, yes.
Okay. Thank you. Yeah, it's okay. So the discrimination was good. That, you know, statistically the algorithm for Blackboard says, oh, this had to be a good question. If you shift, oh, looks like I have a letter I here that's missing. If you shift the binary value 0, 1, 1, 0, 1 column to the left, the 1, 1 is right here, and I have a 0, 0 there. It says, what's the final decimal value? There are only 2 decimal answers that are provided, 3 and 12. If I have a 1, 1, 0, 0, the answer is 12. You'll see some students chose 1, 1, 0, 0. So this was kind of a trick question. What happened here is that they didn't catch the term decimal. If we shift the binary value 0, 1, 1, 0, 1 column to the left, and the question reads, what is the final binary value? This would be correct. But we're asking for the final decimal value. If we said hexadecimal value, what would that be? What's the hexadecimal equivalent of
C.
Correct. I could list C there. I could have a decimal value. I could have, yeah. And if you saw a C there, you'd know, okay, it's asking for hex. Any questions? Okay. All right, so at this point, what we'll do is start looking at, all right, so were there any final questions about how to reconcile? And from what we covered yesterday?